Hello, everybody, and welcome to today's Flipgrid Live Event. I'm Anne from Team Flipgrid, and today we are joined by George Miller from Buffalo Bill Center of the West. Before we get started, let me just say, if you don't know what Flipgrid is, it's a free video discussion platform from Microsoft, and we're on a mission to empower everyone on the planet to share their voice and respect the diverse voices of others. That's why we're so excited about today's live event. Buffalo Bill Center of the West is in Cody, Wyoming in the United States of America. And they're passionate about sharing the epic stories and honoring voices of the past through the stories of Yellowstone and the American West. In just a moment, we'll be joined by George Miller, who loves helping others explore and discover. He creates content for Buffalo Bill Center of the West, and today he's going to tell us all about the life cycle of the great mountains that make up the West. So, without further ado, here's George.
George Miller from the Buffalo Bill Center of the West in Cody, Wyoming. And I want to welcome everybody that's joining us today. We've got people from, looks like Miami, Toronto, New York, New Jersey, Los Angeles, England, Iowa, Missouri, all around the United States and all around the world. So welcome, and I'm glad to see you here today. If you're joining us here today, you can put your questions in the chat and we'll talk about those questions a little bit later. I'm going to talk to you today about building and recycling mountains. So that will be the main presentation, and then afterwards we'll have time for a selfie, we'll have time for questions and answers, and we should have a good time today. So let's just jump right in. Well, I've got something to show you right here. This is a volcanic bomb. Now, it's not a real bomb. It's a piece of lava that came out of a volcano a long time ago here in the Yellowstone ecosystem. And it's called a volcanic bomb because on the way down, it cools and forms a skin over the top, and then it stays intact when it hits the ground. Boom. So these volcanic bombs are part of what we're going to talk about today. We're going to talk about volcanoes, because that's one way mountains get built. We're going to talk about uplift, because that's another way that mountains get built. And then we're going to talk about the things that recycle mountains. Now, we usually think about recycling cans and plastic and cardboard. Those things are pretty easy to recycle and happen very quickly, but recycling mountains takes a long, long time. So let's jump right into it and think about the Rocky Mountains. So that's really what we're going to be talking about mostly, but this applies to other mountain ranges as well. The Rocky Mountains are a huge group of mountains that run all the way from Canada through the United States down into Mexico. And they were formed in a very interesting way. And let me share with you my screen. So I'm going to share my screen right now. Boom. And we're going to go there. All right. And let's take a look at this slideshow from the beginning. Mountain building and recycling. Well, uplift is the way that the Rocky Mountains were built. Well, what is uplift? Uplift happens when two plates of the Earth collide. So we've got continental plates and we have oceanic crustal plates. The crustal plates are heavier than the continental plates, and so they usually dive under when the two crash into each other. This is what happened in North America a long time ago. Starting about 80 million years ago, the Rocky Mountains started being built, and they are folded ranges of mountains that took about, well, from about 80 million to about 35 million years ago was the major Rocky Mountain building phase. So you can see in this plate that the oceanic crust is diving underneath that continental crust, and those Rocky Mountains got folded up in the air. Well, let's see what that looks like in real life on the ground. Here we are in northwestern Wyoming at the Clark's Fork of the Yellowstone River, the mouth of the canyon. And look at those orange cliffs. Those are sedimentary rocks that were deposited lying flat. but now they've been uplifted by that process we just talked about. And they look kind of like pancakes that are now twisted. Now, these pancakes look like they're falling right off the table onto the floor. They've been uplifted so much that those formerly horizontal plates are now vertical. Isn't that an amazing sight? Here we are in the Bighorn Mountains, and you can see these mountains were uplifted as well. You can see those formerly flat structures are now lifted way up into the air. The heights of the mountains are evident here in these slides. Now, you think about rock getting bent, and here is a huge fold in the earth. Look at that cliff. It's going along, and then suddenly it starts to die down. Now, how do you bend rock? Rock seems so solid and hard, but given enough time and enough pressure, rock will bend. So this is called a syncline, and it is very striking how these two pieces of earth have been bent by forces that take a long, long time, shaping the earth. So uplift is one way that the Rocky Mountains were formed. Now, the other thing that forms mountains in our area are volcanoes. And here we are in Craters of the Moon. Craters of the Moon is a national site that's just to the west of me, west of Yellowstone. And it had volcanic eruptions starting about 2,000 years, well, continuing till about 2,000 years ago. So very recent volcanic activity here in Craters of the Moon. And we can take a look at some of the different kinds of processes that volcanoes form here in the Western United States. So here, look down into the hole where the lava came out. Those are called vents. And this is a splatter cone. So big chunks of lava would have flown up out of those holes or vents when the eruption was going on, and it kind of welded together on the side of this crater. These are called splatter cones because they're big splats of lava that come out, and they're so hot and molten that they will adhere to the other pieces of lava as they come out. Isn't that an amazing sight? So it then forms a cone around the vent and a little crater actually in this one. But look at that. Pretty amazing sight here in Craters of the Moon. And if we look off in the distance, we can see a different kind of cone. That's a cinder cone. So we'll talk about the different kinds of lava in just a minute. What I want you to look at is this lava right here. It has so many holes in it because when lava comes out of the earth, many times it has lots of gases trapped inside of it. And then as it cools and hardens, those bubbles of gas are shown in the lava. Isn't that amazing? So this is a huge area that's had fairly recent lava flows. Well, there are different kinds of lava, and the first kind that I want to show you is called Pahoehoe lava, and that's a Hawaiian word. It's kind of fun to say, Pahoehoe. That Pahoehoe lava is kind of smooth and like a wave flowing down the hill. And then this other lava that's rough and textured like this is called A'a lava. Another Hawaiian term, A'a lava, is that broken up lava. So Pahoehoe and A'a lava are two different kinds of lava that we can see here at the Craters of the Moon. Now, here is a third kind of lava, and these are cinders. So from a cinder cone, very violent eruptions break the lava into little tiny pieces, and there you can see all three of them. In the foreground is the cinder, and then the Pahoehoe lava, and then the A'a lava, all in one place at the Craters of the Moon. Well, let's get focused in on Yellowstone because that's really close to me. We live in Cody, right near the east gate of Yellowstone National Park in the United States, and it's a pretty amazing place. And there's a hot spot under Yellowstone, a magma plume right under the park itself. Now, if you look off in the distance at those mountains, those are the Absorka Mountains, and they were formed by huge volcanic eruptions about the same time that the building of the Rocky Mountains started. But this is called the Absorka supergroup, and they have huge amounts of lava that have formed mountains. The Yellowstone hotspot is a track of volcanic eruptions over the past 17 million years ago. As the North American plate has moved across the hotspot, we've seen lots and lots of different volcanic eruptions. And these are not small volcanic eruptions, these are supervolcanoes. So you might have heard that word supervolcano before, and we have one here in Yellowstone. About 2 million years ago, the Huckleberry Ridge explosion or eruption was huge. And then the Island Park caldera about 1 million years ago wasn't quite so big. And then the Lava Creek about 640,000 years ago was gigantic. And these eruptions would spread ash into California, out into as far south as Texas, up into the Canadian border, and out past the Mississippi River. So these are gigantic eruptions on a scale nothing that humans have ever seen here in North America. Here's an explanation of the caldera forming volcano in Yellowstone National Park. Now, a caldera is like a huge pot. So if you just think about this giant pot being formed, so the magma plume comes up under the surface and melts till it can get through cracks in the earth, and then suddenly all that pressure is released, a huge explosion, and then a collapse. And so that caldera finally collapses. And the last time it did it, it was like 3,000 foot deep caldera that was formed. And then that gets filled in with later lava flows. But we can still see the caldera here in Yellowstone National Park. Well, we've talked about what builds lavas. Now let's talk about what builds mountains, but let's talk about what recycles mountains. So we've got glaciers and rivers in our area are the big movers. This glacier is I took 2 summers ago when I was up in Anchorage. This is the Mendenhall Glacier. We still have glaciers here in our area. They just aren't quite as big as that. So here is the up in the Absorka Mountains, and we're looking at big snowfields. So we have permanent snowfields here in the Beartooth and the Absorka ranges, but they aren't glaciers. We do have a few glaciers. So what needs to happen is more snow falls in a year than melts. So then soon that snow gets thicker and thicker, and when it forms enough thickness, the ice starts to move at the bottom and it will start scraping away the land. And that's when it becomes a glacier. Well, these 2 peaks here, Pilot Peak and Index Peak, were never overtopped by the glaciers, but in between them and around them, glaciers flowed and scraped the earth away. And that's why we have these really striking and beautiful tall peaks here in the Absorka Beartooth area. Gorgeous, gorgeous mountains. Well, we can see a huge glacial valley here. This is the Sunlight Valley, and it looks kind of like a big U, and that's very typical of glacial valleys. So the ice came down this valley and just scraped all that earth away, leaving these huge glacial valleys. And you can see where the snow has piled up here, and then it will start to run off. So glacial valleys were a big mover up till about 10,000 years ago in our area, and now most of those glaciers have melted. And what now moves most of the earth around is rivers. And you can see me here standing next to the Clark's Fork of the Yellowstone River, and it's carrying away rock and debris. And if you look into the river, you can see all those rocks in the river, and they'll eventually get washed further downstream when there are big floods that come through. And let's take a look at the another river in our area, the Grabel River. So you can see the mountains where most of the snow falls, and then in the spring, as that starts to melt, it starts coming down the Grabel River, and you can see how it's channeled. And look at all the rock in the riverbed. That's all formerly mountains. So they're being washed away down river, and you can see all that snow gets channeled down into these riverbeds that then run off, and you can see that's that water's pretty dirty, and those gravel bars are evidence of erosion. And then this is the Bighorn River, and look how muddy that is. And the Bighorn flows into the Yellowstone, that flows into the Missouri, that flows into the Mississippi, that flows out to sea. I've got my volcanic bomb here. And so if you want to take a selfie with me with this volcanic bomb, that might be a fun thing to do. And I'll just hold real still and you guys can gather up and take your selfie.
All right, that's great, George. It looks like Anne might be having some issues on her camera joining us. Okay. So I'm going to jump in and ask you some questions. We have a question here from Kat, and she's wondering, can mountains get?
She's wondering what?
How big can mountains get?
Well, we have some mountains in the world that are very big. For example, the Himalaya Mountains are the highest in the world. That Mount Everest, you might have heard of Mount Everest. And what's happening there is the same thing that happened with the Rocky Mountains. It's uplift. The Indian subcontinent is running into Asia, and that folding action is actually pushing those mountains up even higher. So we have mountains that get up to 28,000 feet. The mountains here in the Yellowstone ecosystem are over 13,800 feet, and then further south in Colorado, in the Rockies, 14,000 feet. So over 14,000 feet. So we've got really high mountains, and they can get very big depending on what that geology is doing. Now, the Rocky Mountains have stopped building, and so they're getting eroded. So they're actually generally shrinking a little bit. Although once in a while we get an earthquake and they grow a little bit. But that erosion is faster than the growth now.
That is so cool. I have another question here from Mrs. Olson's 4th grade class. Does the weather affect the mountains?
Absolutely. So we've got a number of different things that affect the mountains. Weathering and erosion. So the big erosion, and I like to think of erosion as happening fairly quickly. You can see erosion in a big flood, or you can see erosion over a couple of years with spring runoff or even a glacier. Weathering tends to be a somewhat slower process, so wind erodes mountains, and also the freeze and thaw cycle erodes mountains. So that will actually break rocks apart, and they'll fall apart when they freeze and thaw over the year. The water gets in there and expands and breaks the rock apart. So erosion is also a part of it, but weathering also happens. So that weathering is very, very important for breaking down mountains and recycling.
That's amazing. I have another question here from Luella, also in Mrs. Olson's 4th grade class, and you're going to like this one, George. She wants to know, how did you become so passionate about mountains?
Well, I grew up in the mountains, and as a boy, I was always out hiking in the mountains, and I would see these big, huge rock cliffs, and I always just wondered, how did that get formed? And so all my life, I've spent a lot of time in the mountains, and now I live here. I've lived here for the last 20 years, right next to Yellowstone, and there's so many interesting things about rocks here. And I spent last summer, because we were in quarantine, I spent last summer going around the state of Wyoming and filming the different mountain ranges that we have here and studying the geology. I don't know. I just think rocks are pretty cool.
I like that. That's awesome. And then we have another question from Miss Portia's 4th grade class. Naomi asks, does water or sea have anything to do with mountain uplift?
Does what?
Water or sea have anything to do with mountain uplift?
Yeah, not so much. Water has more to do with tearing down mountains, but that slide I showed you about the ocean crust that's going under the continent, that has a lot to do with it. And that ocean crust is formed at the ocean ridges where there are volcanoes that are actually creating new crust in the ocean floor. And as those spread out, they move, and sometimes they run into, those plates will run into continental plates, and that's what causes that folding. So if you think of it maybe like a piece of paper, and this one's just staying still, but this one's pushing on it, look what happens to the paper. It gets pushed up in the air. So that's a good analogy for what happens for that mountain building phase of the Rocky Mountains.
That's pretty amazing. It's crazy to think that something so big could be scrunched down like that.
I know, isn't it? Yeah.
We've got some questions here about volcanoes erupting, and here's the first one. What would happen if Yellowstone erupted?
Well, I think our feed would get cut off pretty quick. Yeah, when Yellowstone erupts in a major eruption like that, it's huge. I mean, it's very, very big. It would impact a number of states here. We would be in a long period of recovery. But the thing about that is, it's probably not going to happen for a long time, because that plume has to melt crust to get re-energized, and that's not going to happen for probably some million years or so. What does happen more often in Yellowstone are steam explosions. When pressures change, especially underneath the lake, we get these gigantic steam explosions, and they can be pretty big, not like the volcanic explosions, but those are much more likely to be seen in every few thousand years or so. But the volcanic eruptions, there's usually a long time period between each eruption, so we don't have to worry too much about it. But when it goes, it'll be very, very big event.
On that note, we've got Evie from Mrs. Olson's 4th grade class. Lots of questions coming from there. Is there going to be a volcano that will erupt soon?
Well, we actually have 2 volcanoes that I know of. I mean, there's probably more than that right now, but 2 that have been in the news recently. One is in Hawaii. There's some eruptions inside the Kilauea crater, and then in Iceland, some of the vents have opened up, and there's some really cool pictures right now. If you Google Icelandic volcanoes, and you can see these just rivers of lava flowing out of these vents, and that's really cool to see that in real time.
Speaking of lava, we've got LC4 Virtual School Grade 5s, and they want to know, how can some of the lava be bubbly, but others are not?
Okay, well, it depends on a number of different things. It's pretty complicated, but it would be heat and heat, how hot the lava is when it's coming out, how much pressure it's under, and how much gas it has. So that how much gas it has is what kind of rock it's melted. Will have different compounds in it that will produce different kinds of gas, and that will all get mixed together. So that's going to determine what kind of lava, whether it's cinder, whether it's pahoehoe or will be determined by the kind of rock that was melted and how much heat and pressure the lava's under before it comes out of the ground. Now, I hope everybody remembers, and I'll just remind you guys, we have 2 different words. We have lava, and that's after it's out of the ground, and then we have magma, which is one of my favorite words. It's kind of fun to say, magma under the ground. So the magma under the ground is melting rocks around it, and that will contribute different kinds of chemicals and different amounts of gas to the lava.
Lots of questions about lava and volcanoes. People are excited about this.
Yes.
I have a question. Can volcanoes, this is from Sarah, can volcanoes re-erupt?
Yeah. So many times volcanoes will go dormant, what we call dormant, and we think they're like sleeping, and there doesn't seem to be much activity around those volcanoes. So we won't have any seismic activity, any earthquakes. Earthquakes are pretty common around volcanoes because the magma is under the ground shifting around, and it causes little earthquakes. So sometimes volcanoes will go dormant, and then they'll come back to life. So yeah, they can re-erupt. But generally, we have, what makes me sleep at night is we have what's called the Volcano Observatories, and we're observing all the active volcanoes in the country. And we have seismographs around them, and we can figure out what's going on. And we look for little earthquakes to see if they're going to erupt soon or not. So that makes me sleep at night. We can tell if one's active or dormant.
And when it goes from dormant to becoming active, like what happens to tell us that that's what's going on?
Yeah, we'd see lots of little earthquakes happening, micro earthquakes, and then sometimes there's bulges in the earth if the magma's moving up into the magma chamber. So we generally have a good idea, and the warning systems are getting better and better around volcanoes, being able to give people some warning at least before a volcano goes off because of those seismic monitors. And here in Yellowstone, we've got a lot of seismic monitors. This Volcano Observatory around Yellowstone is big and it's very extensive. And you can go on real time and see the volcano observatories too. So that's another resource that's available.
And how much of a warning would we get?
Well, that's the trick. Yeah, with Yellowstone, because it's so highly observed, we know basically what's going on all the time in Yellowstone. So we would have plenty of advance warning. But some other places, if they don't have that kind of a network, the time frame would be smaller. But generally people are getting hours to days before a volcano goes off, when they can people are going to be able to be warned and say move away. And generally there's some sort of little steam explosions and things that happen first before a volcano really goes off. Generally that doesn't always occur, but yeah, people generally have good warning.
This is a question from Mrs. Esposito's 3rd grade class, and they're wondering, why are some volcanoes on the ocean floor?
Yeah, so remember we talked about those plates, and this is another whole topic that we could go into. They're called tectonic plates. There are different plates in the earth, and some are on the ocean floor, some are continental plates that sort of float over the top of that. And where there are intersections between two plates, that tends to be very active in terms of earthquakes, and it tends to be very active in terms of volcanoes as well. So they can blow up under the sea. Now, that lake I showed you, Yellowstone Lake, even under Yellowstone Lake are vents, and everything you see on the surface at Yellowstone, like Old Faithful, all the geysers and everything, is going on underneath the lake too. We just can't see it because all that water pressure keeps those things just down at the very bottom of the lake. In fact, there was a scientific research this last year, and they brought, or the last, I think 3 or 4 years, and they brought a tiny submarine into Yellowstone Lake and went down and observed those vents on the bottom of the lakes and on the bottom of the lake, and they found one vent that was like 340 degrees Fahrenheit. So really high temperatures because of all that pressure with the lake water over it. So yeah, underwater there are volcanoes just like on land.
That is amazing. And now, George, I know you've created some pretty fun topics for the Flipgrid Discovery Library. Do you know what some of your most popular topics are?
Well, this geology one's turning out to be very popular, but also another one we have is called animal adaptations, and that is probably our most popular topics.
And what is an animal adaptation?
Well, all animals have physical adaptations and behavioral adaptations that allow them to survive in their environments. And in animal adaptations, we talk about animals, particularly here in the Yellowstone ecosystem, and how they adapt to the different environments here in Yellowstone.
That is so cool. I have an idea, George. What if we create a topic right now together?
Okay. That sounds great.
Awesome. Well, while you're thinking of that topic, I just want to share something with educators and parents. We're about to create a brand new topic, which you'll be able to view in Flipgrid. It's basically a discussion prompt, and you'll be able to use this immediately with your students to have them share their learning from today's live event. You'll be able to find this topic in the Flipgrid Discovery Library on the Buffalo Bill Center of the West partner page. We'll share a link in just a moment. All right, George, it's go time. What's the takeaway topic from today's live event?
Well, you know what I'd really like to know? What I'd really like to know is what you took away from this event. I mean, that would be kind of a cool way to look at it. What did you think was most interesting, or what did you learn that you didn't know before?
That is an amazing prompt. So you can go ahead straight to the Discovery Library right away. So you can use this. So after this event, everyone at home will post this link in the chat. You're just going to type aka.ms/Flipgrid Buffalo Bill in your browser. So we'll post that link in the chat for everyone to copy. George, I can't thank you enough for taking the time to tell us about the mountains of the West. Any final thoughts you want to share with everyone while watching?
Well, you know, I'm just so excited about learning about science is always fun. And even something like a mountain that we think is so solid gets recycled. So lots of fun stuff to look at, and especially on Flipgrid, there are lots and lots of topics there.
That's awesome. All right, George, and everyone else at home, thank you all so much for joining us. We're so grateful that you all shared some time with us. Be sure to go to aka.ms/Flipgrid Live Events to sign up for more events just like this one. We hope you have a beautiful day.
All right. Bye-bye.